years since I've been at conference, and for some of you, you may wonder, what have I been up to? I've been working on my PhD for the past forever, it feels like, but past 4 years. And I just kind of wanted to share with you a minute before we got started about part of the motivation that I had to get my PhD. And it was you guys. I don't get to meet each and every one of you, unfortunately, but the stories that people have talked to me about inspired me to be able to give more of a foundation for the research. We know things work, but why did they work? Let's try to get some science behind that. And so you're part of the reason that I've worked on my PhD. The other part is I wanted to become a better researcher so that I could put more meat in the research and add a lot more value to the body of literature that's out there. So those have been my goals, and that's what I've been working on. But just know that you've been an integral part of that, and that your stories, even though I can't meet each and every one of you, have been a staying force to get through this, because I think it's a value and an important thing for all of you to have some foundation in the sciences behind everything that you do with the oils. So, sorry, let's try to, there we go. So this study was done a few years ago, and it was the effects of doTERRA OnGuard. OnGuard is one of my favorite oils, and I wanted to learn a little bit more about how they worked. So this all started a few years ago in the hospital that I worked at. We began seeing an increase in a health issue that was causing significant risk to patients. And part of that risk was it was no longer just being found in hospital patients. It was being found in the community, people that had never even been in the hospitals. And as time would go on, about that same time, and this is how things always have a way of working out, a dear sweet friend of mine, Peggy Smith, and some of you may know Peggy. And you all agree. She introduced me to this small essential oil company that was just starting out, and I know all of you now know this company. And after we had began talking to some other staff that worked at the hospital, I began to wonder, with this community outbreak and this huge uptick in this outbreak, I began to wonder how live cultures would interact and respond when exposed to essential oils, and whether the oils could influence the outcome. So, sorry, I went ahead here. So, one of the things that became a problem, and it was very apparent with these organisms, is that, just to give you a little background, various microorganisms can become resistant to standard methods of control. And this becomes a problem when there's limited options available. Some organisms, there's 5 options. That's it. There's nothing else that you have an option to treat with. Well, we all know we do, but anyways, sometimes when they'll finally come out with a new option, the genes inside the organisms have already mutated, and the organisms already become resistant, and the mechanism of action no longer works. So, I guess we're moving on. Anyways, the laboratory experiments, what we wanted to do to study how the essential oils in live cultures worked, we started off with 10 microliters of doTERRA OnGuard and 10 microliters of Melaleuca, and then put them on separate paper discs. And just for some of you that may not know what kind of a volume that is, that's roughly about 1/6 of a drop for the OnGuard. And then the paper discs are just things that we use to, you can impregnate them with any sort of solution that you want to study. And so we use that. It's a standardized method to use to test whether something can be inhibited by whatever you've put on the disc. So we inoculated the plates, and we made what we call a half McFarland. And what that is 1 times 10 to the 8th colony forming units. So it's actually quite a lot of organism, but they're very small. And we struck it out on a plate, and then we put the discs on, incubated the plates for 18 to 24 hours at 35 degrees Celsius. And for some of you that don't know, that's basically internal body temperature. And then we compared the results. And here we see that overall, OnGuard had a 26% increase in zone size inhibition in comparison to Melaleuca. And that hadn't really been published in the literature or anything, so that was pretty exciting information. So we wanted to expand that a little bit and see what else would go on. And so we decided to increase the concentration of OnGuard that the organisms were exposed to. We went from 10 microliters to 20 microliters and then to 30 microliters. And as you can see, once we oversaturated the discs, the efficacy decreased slightly. So more is not always better. You can be very effective with a smaller amount. So from this study, we concluded that doTERRA OnGuard is more effective than Melaleuca, and that increasing the volume of the oils does not increase the effect on the organisms. But I wanted to be, that's all good and fine to have it in the scientific application and to be able to say this is what happens in the laboratory. But I'm a pretty practical person, and so what are some practical applications? And so what we did next was we decided to study some surface cleanings. So this was a smaller study, and we added 3 drops of OnGuard to a 32-ounce spray bottle and filled it with tap water. This wasn't any fancy water. It wasn't distilled. It wasn't bottled. It was just regular tap water. Obviously shook it up. And then we sprayed a surface with the solution and allowed it to air dry. And I realize for some of you, air drying is not a possibility. But I'm for Colorado. It doesn't take too long for things to dry. And then we added a suspension of the microbes to the surface and we allowed it to dry. And so what we were doing was seeing if the organism was going to be able to survive. So we surface swabbed this culture, surface swabbed the surfaces for every day for 7 days. And so what we did is we took a swab, we inoculated it onto plates to see if the organism would be able to grow. And I probably need to take a step back because most people don't realize this. A vast majority of microorganisms, whether it's fungus, parasites, bacteria, viruses, can survive on surfaces for quite some time. Some things only survive maybe 2 days, others are 7, 14 days even. And they're surviving on surfaces where there's no food for them. But once they get into contact with a surface that can provide food, like your skin or an agar plate or something like that, they rapidly revitalize and start growing again. And so we wanted to test that to see, because we know certain organisms can survive 7 days, 14 days on surfaces. So that's why we went ahead and swabbed each surface for 7 days and then cultured it to see if it could grow. The organisms were not recovered from the surface. Organisms that are supposed to survive on dried surfaces, when we had sprayed it with the OnGuard, they weren't able to survive. And I hope that you guys can grasp that, because it's really it sounds simple, but it's really a big deal. Can we protect our surfaces? That's pretty awesome. And so I really want to do a much larger study now, because this was a smaller study that I did a few years ago. I want to change it up a little bit, do some other surfaces. We just did like a countertop surface, but I would like to also be able to do stainless steel, and maybe Dr. Winterton will loan me a prosthetic knee and we can borrow it and do some studies on that as well. And just test different surfaces, do it with the OnGuard spray on first, and then the different organisms as well. And then I'd also like to do it the other way around, where we would kind of flip it over, where we're doing not only we'll put the organism on the surfaces first, and then spray it, let it dry, and then spray it with the solution, and then see if it can survive or not. And one thing I want to note is, because sometimes, like, when people are told to wash their hands when there's a C. diff infection, the actuality is they're washing the spores off their hands. They're not really killing the organism. And so one of the things I want to point out is we were not wiping the surfaces. We weren't wiping the organism off. We were just allowing it to sit there and air dry. And so that's really an important factor. The organism was interacting with the oils, or the oils were interacting with the organisms, and we couldn't bring them back to life. And so, like I said, I want to do a yeah, that's really exciting. You guys, you may not think because I'm a microbiologist, I'm a little bit of a germaphobe. I don't want them and the bad guys around me too much. So to be able to validate that this is a good surface protector, a surface cleaner, those sorts of things is really important. And so I'm hoping that we can do a much larger scale, be able to continue to validate what we're doing, and to be able to maybe prove some of the mechanisms involved with that. And so those are some of the things that I hope to do in the future, and hopefully get published as well soon, once I get those initials after my name. So you'll hear about it. You'll know. And I have a couple of minutes, so this was a smaller experiment, like I said, but I just have a couple of minutes, and I just wanted to share something with you guys. There's so much positive energy in this room, and I just want to, this is nothing to do with bacteria or viruses or parasites or fungus, but one thing, we talked a lot yesterday about yoga and meditation and centering, but one of the things that I just wanted to share with you real quick, the thing that helps center me the most is doing random acts of kindness for other people. And there's something wonderful about doing something for somebody else, and it's even better if they don't know that you did it, I think. But anyway, so there's 30,000 people here. There's another 10, I've understood, watching online. What if we all did a random act of kindness today? Just a thought. Thank you.